Here's our own Dr. Tamitha Skov.
Just as space weather begins to worsen for amateur radio operators and emergency responders, it picks up for aurora photographers. As we switch to our front side sun, you can see that bright region. That is a solar cycle 25 sunspot. That's region 2752. And you can watch it kind of fizzle and fade out as it rotates across the disk. You know, these new cycle sunspots, they don't last very long yet, but they're getting stronger. But just above that region, you can see that decent sized coronal hole. That is going to be bringing some fast solar wind here in the next day or two, and it could bring aurora down to mid-latitudes. The jury is now in. A new paper just out in Nature Astronomy has confirmed that Jupiter's moon Europa does indeed spout water vapor plumes from the oceans beneath its icy surface. Although NASA's Hubble Space Telescope has long spotted indirect evidence of these water plumes, until recently they only had a smoking gun. Now, along with observations made over the course of 17 days in 2017 from the Keck Observatory in Hawaii, researchers struck gold. Water. On April 26, they unexpectedly received a strong signal, a special kind of infrared light that can only be emitted by water. And there was quite a bit of the stuff too, about 2,100 metric tons according to the researchers' estimates. That's almost enough to fill an Olympic-sized swimming pool. Now, along with the other observations, this massive amount of water is proof positive that this indeed is a water vapor plume shooting out of Europa's surface, as no other known process in the Jovian system can account for it. Not even Jupiter's intense radiation belts could strip enough water molecules from the surface of Europa to release that much water vapor in its atmosphere. Not to mention Jupiter's radiation belts, they would create a continuous release of water, not just one massive plume. So understandably, this news has got astrobiologists talking. In the search for life on other worlds, these water plumes are like little messengers from heaven, shooting samples of possibly habitable environments right out into space for us to fly through and measure using orbiting spacecraft. Who needs a lander? In fact, this is exactly what the NASA mission Europa Clipper is betting on. Scheduled to launch in the mid-2020s, it will orbit Jupiter, having many chances to get up close and personal with a possible plume through dozens of Europa flybys. Clipper's aim? To chart the moon, its ocean, and search for spots where a potential life-hunting lander could touch down on the icy surface in the future. And if the mission team members learn enough about these water vapor plumes in the coming years, Clipper might just wind up zooming right through one. Now, what would it mean to you if we found life on Europa? For more details on this week's space weather, including when and where to see aurora, how your GPS reception will fare, and how amateur radio is doing, come check out my channel or see me at spaceweatherwoman.com.
If you're on Twitter as much as I am, you've probably seen the astronomical community is kind of having a little bit of a freak out about SpaceX's recently launched batch of Starlink satellites. There's been lots of images of fields of view being studied that end up having them zipping straight through it and absolutely wrecking the data being taken. Now, a lot of people are saying that we should just launch more space telescopes. It's not that easy. But that's for a discussion a little bit later down the way. But there is a space telescope that we do want to talk about here called NICER. It is up on the International Space Station. And to talk about a recent high energy result from it, here is Manju Bangalore.
So Jared was just talking about Starlink. And I think that global access to the internet is a fundamental right. But I also understand why astronomers might be a little angry. Perhaps the future of astronomy lies in a compromise. In the near future, astronomers may be able to fully rely on space-based astronomical platforms to collect data and observe the universe. The NICER telescope, sitting outside the International Space Station, observed something pretty incredible back in August. The neutron star Interior Composition Explorer observed X-rays shooting out of a pulsar in the Sagittarius constellation 11,000 light-years away. Pulsars are condensed cores that are rapidly spinning after the death of a massive neutron star. This pulsar, called SAX J1808, draws on its nearby brown dwarf star for hydrogen gas and then pulls it into an accretionary disk. Every now and then, the accretionary disk becomes too dense for itself and the hydrogen gas ionizes. The pressure and temperatures increase, causing nuclear fusion, and after a while, a thermonuclear burst blasts across the surface of the pulsar. This binary system is especially unique for two reasons. One, it's a millisecond accretionary pulsar. Now, neutron stars are rare. Pulsars are even rarer. Accretionary pulsars are even more rare, but millisecond accretionary pulsars, only 13 of them. And we happen to catch one of them releasing a massive, massive burst. But the more important reason is that the brown dwarf star orbiting the pulsar only takes 2 hours to complete its orbit. So basically, it can complete 600 revolutions by the time you finish a Lord of the Rings movie. I also want to know, did other objects around the pulsar survive the supernova explosion, and could they be exoplanets? At the beginning of the burst, the brightness decreased for less than a second. And in this short time, scientists think that the star built enough energy to push its hydrogen layer into space. In 20 seconds, the X-ray burst released as much energy as the sun releases over the span of 9 days. To date, it is the brightest set of X-ray pulses NASA has ever observed. What a brilliant sight.
And of course, we want to give a huge shout out to all of the citizens of tomorrow. Without your help, we wouldn't be able to make any of this possible. No news, no letting off steam, absolutely nothing. So if you got something from us and would like to give something back, you can head on over to youtube.com/TMRO/join, and you can always head over to community.tmro.tv to find other ways to help. As always, hitting that subscribe and notification button, liking, sharing, and getting us in front of as many people as you can helps make it possible for us to pursue the core of our mission here at Tomorrow, which is to get everyone excited about space. So until the next space news, keep exploring.